Okay, so now let's do a problem with a concave mirror. So for a concave mirror, I'm looking at a tree and I see an inverted image of the tree that's 3.5 centimeters high. So the height of the image is 3.5 centimeters. And because it's upside down, I need to put its height as negative. So it's inverted. And it's located 7 centimeters in front of the mirror. So the image is 7 centimeters, so that's DI is 7.0 centimeters. And in this case, the image is in front of the mirror. So in front means it's real. And so it's going to be a positive DI. All right, if the tree is 21 meters from the mirror, so the tree is the object you're looking at, so that's DO is 21 meters. I need to convert that to centimeters. Right, why did I convert this one to centimeters? Because I already had two numbers in centimeters, so it's easier just to convert one of them. All right, so it's 2100 centimeters. And I want to know what's the height of the object. So what equations do I have? Well, I've got magnification is equal to the height of the image over the height of the object, which is minus DI over DO. And I also have that 1 over F is equal to 1 over DI plus 1 over DO. So if I want to know the height, I need to use the equation for magnification. All right, so what do I know? I know the height of the image, I know the image distance, I know the object distance. So I can set this equality, cross multiply, and solve for HO. So let me do that. So HI times DO is equal to minus DI times HO. So let's see, what am I trying to find? I'm trying to find HO, so let me divide both sides by minus DI. So I get height of the image is minus 3.5. Object distance is big, 2100, divided by minus the image distance. Image distance is 7. And if I put that in, I get 1050 centimeters, or 10.5 meters. Okay, how big is that? That's about 30 odd feet. All right, so something like 35 feet. That's pretty reasonable for a tree, right? That's sort of a number that we might expect. Okay, so what next? So I've got the height. What's the focal length of the mirror? Okay, so now I want to find the focal length. Focal length is F. So now I'm going to use that second equation. So I know DI, I know DO. So I just have to plug it into that equation to solve. So I've got 1 over the focal length is 1 over DI plus 1 over DO. So that's going to be 1 over 7 plus 1 over 2100 is equal to 1 over F. And I want F. So F is going to be 1 over that number. So F is going to be 1 over 1/7 plus 1 over 2100. And so I get a number that's 6.98, and that unit is in centimeters. Okay, so the focal length of the mirror is 6.98. Yikes. It's 6.98, which is approximately 7.0 centimeters to 2 sig figs. All right, I got a positive number, which is what I expect because it's a concave mirror. F is positive. So usually when I do calculations like this, I usually do a quick sketch just to make sure that what I'm getting is correct. All right, so let me just do a couple of special rays. So usually I just use the 2 easiest special rays in order to get my number. So let me draw, there's a concave mirror, and I'm going to put my tree, I'm going to draw the object as an arrow. And here's my focal point. All right, so my object is well outside the focal point. So ray number 1 comes in parallel and goes out through the focal length. So there's through the focal point. So there's my ray number 1. Ray number 2 comes in through the focal point, goes out parallel. Oops. see if I can do that. So in through the focal point, hits the mirror, and then when it hits the mirror, it turns around and goes out parallel. And remember, when we say it comes in through, what we mean is it's coming in from the top of the object arrow. All right, so I've got two rays here. So from these two rays, I could already draw my image. The image tip of the image arrow is where they meet. The tail of the image arrow is going to be on the principal axis on that line that I have here. So there's my image. I could draw the third ray. So another simple way to do is just to go from the tip of the arrow to the center of the mirror, and then to bounce out at the same angle it came in at. So that would be a third ray. So you can pick any two rays that you want, whichever ones you can remember, and you see that it gives me the same result. So this tells me from my sketch, I can see that the image is inverted, it's upside down, it's smaller, the height of the image arrow is smaller than the height of the object arrow, so it's smaller, and it's real because the light rays really go through it. It's on the side of the mirror that the light goes on. Remember, the light can't go on the back side of the mirror. Anything that's on the back side of the mirror is virtual.